Okay, wrapping up almost, guys. Only a couple more. All right, so electronegativity and bond polarity. The electronegativity values of representative elements in group 1A and group 1,7. So you can see the non-metal, the name of the formula of the ion, and then the name of the ion. So what we're going to do for this video is use electronegativity to determine the bond polarity. So electronegativity value of an element indicates the attraction of an atom for the shared electrons in that bond. The electronegativity increases from left to right going across the period on the periodic table, and it increases from the bottom to the top of the periodic table. So again, when they organize the periodic table of elements, it's a great layout because it makes sense, okay? It's high for nonmetals, with fluorine being the highest, and it's low for the metals. And so our core chemistry skill is using this and figuring out what to do with it. Okay, so here is, again, electronegativity increasing and decreasing across and down. So that is a good little summary to remember. So nonpolar and polar bonds. In the nonpolar covalent bond of hydrogen, the electrons are shared equally, where in the polar covalent bond of hydrogen chloride, the electrons are shared unequally. Okay, so you can see equal sharing where it's unequal sharing. Okay, and this makes a big deal. So nonpolar covalent bonds. A nonpolar covalent bond occurs between nonmetals. It's an equal or almost equal sharing of electrons by two bonding atoms, and it has a very small electronegativity difference. And some examples would be two nitrogens binding, a chlorine and a bromine, right? And so the electronegativity difference would be 3 to 3 minus 3 is 0. 3 minus 2.8, the difference is 0.2. 2.1 minus 1.8 is 0.3. And so the type of bond for all of these guys are going to be the nonpolar covalent. And like I said, they're almost equal sharing, and so they has a very small electronegativity difference that you can see with these calculations we just did there. Moving on to polar covalent bonds. A polar covalent bond occurs between nonmetal atoms, and it is an unequal sharing of electrons, and it has a moderate electronegativity difference. So again, remember those other ones were really close to 0, where these, when we subtract them, were between 0.5 and 1, and so you can see that there is a difference in pole or polarity. When we're talking about dipoles and bond polarities, a polar covalent bond becomes more polar as the difference in electronegativity increases. The separation of charges in a polar bond is called a dipole, and the positive and negative ends of the dipole are located using the lowercase Greek letter delta with a positive or negative charge, and an arrow that points from the positive to the negative end of that dipole. So example here would be carbon to oxygen, right? The direction of the arrow, nitrogen to oxygen, direction of the arrow, plus minus. So you can see that's how we're going to be labeling them. An ionic bond occurs between metal and non-metal ions, and it is the result of a electron transfer. So they're not sharing, they're giving. And it has a large electronegativity difference of 1.8 or more. So remember, the other ones, it had very, very small electronegativity difference, and then we had moderate, and now this one's going to be a very severe or large electronegativity difference. So you can see when we subtract them, we're in the 2s, like, you know, it's big, okay? So that's one way that we can tell what type of bonds are going to be in there. The difference in electronegativity values for two atoms can be used to predict the type of chemical bonds. So again, if the electronegativity difference is small, between 0 and 0.4, then the bond is nonpolar covalent. Where if the electronegativity is between 0.5 and 1.8, that moderate, then that's going to be polar covalent. Where if it's larger than 1.8, then the bond is going to be ionic. And so that's a great way to be able to calculate and figure out what type of bonds we're going to be dealing with. And so again, great little summary table. where we have nonpolar covalent electronegativity difference is very minimal. When we have medium, then we have polar covalent, and the large difference is going to be the ionic bonds, okay? And this is where, again, those ions are going to be transferred completely. So sharing, mostly sharing, but a little bit more greedy, and then just complete separation, okay? Here's a great table on predicting the different bond types, again, by calculations, so we can figure out if it's nonpolar covalent, polar covalent, or ionic based on the difference in that calculation. So let's practice. So using the electronegativity difference to identify the type of bond, what would it be for these guys? So pause me and come back. Okay, so the difference between A is 2.2, so that tells us it's going to be ionic. For B, it's 0.5, polar covalent. Chlorine, chlorine, no difference, nonpolar covalent, and then polar covalent. So kind of just a fun way to do calculations.